For this lesson, we will be looking at errors and debugging while creating and using objects in Java. I know that this may not sound like the most exciting topic, but really, this is an important one, because once you know how to avoid these common errors and to find and fix them when they occur, it will make your programming life much easier. Some might say that this is even the most important topic when learning about objects in Java. So let's get started by looking at the most common error made in Java, and this involves actually creating the object. So students often make the mistake of when creating an object, they declare the reference variable. But in creating an object does not just involve declaring a reference variable, but also creating the actual object in the computer's memory. Here you can see that the reference variable is created, which is b1 in this case, but it is not actually pointing to anything, but it actually acts as a reference to our object. But again, it does not really have a value, and this is symbolized by the dot underneath the b1. To actually create the working object, you must point the reference variable to an actual object in the computer's memory. So in this example, you can see that the reference variable is b1, and it is pointing to our object bike, which in this case has the instance fields of model, color, and gears. Another common error that students often make when creating objects in Java is that they have class fields, which is basically one copy of that field for the entire class. Now, even though the idea of class fields helps to make the program more efficient and easier to understand, it is often easy to make the mistake of trying to change the value of the static variable for one object. But in fact, this ends up changing the value of the static variable for all objects in that class. Take for example this bike class. We have both bike1 and bike2. Now since most bikes only have 2 wheels, our class fields is set for number of wheels, which in this case is 2. But say bike1 is a tricycle, and we want to change the value of number of wheels from 2 to 3. Changing the value of that static variable does not just affect bike1, but it affects all the other objects in that class, which in this case is both bike1 and bike2. Now to avoid this error, obviously you would not create a class field if you know the value is going to be different for the different objects. You would just create an instance field. When comparing objects in Java, it is easy to make the mistake of using the wrong method for comparing them. Take for instance these two objects, bike1 and bike2. They have the same values for their instance fields, the same name, color, gears, and number of wheels. So making them equal each other in Java, you would expect it to return true. However, it will not, because even though they have the same values for their instance fields, they are still pointing to separate objects. This is more easily understood by looking at these two bikes, as they have the same features such as color, size, and name. But you cannot say that they are the same, because they are different bikes with different models, or in Java's case, different objects. We will show you a way of getting around this in the second part of the video lesson, by using actual Java code and showing you additional errors, as well as how to avoid them and fixing them should they occur.
So now we'll show you some actual examples of common errors that people make while creating objects in Java. The examples that we'll be using come from a program that creates the object bike, which consists of a model name, color, gear, and a number of wheels. So before that, I'm going to overview the 4 main variable types we've learned so far. First, there are local variables, and these are the most basic variables that we've used. They can be declared inside of methods and are not automatically initialized. An example of this would be the bike string in the toString method. Another variable type is a parameter, which is declared in a method's header, and it is initialized with the value in the method call. So examples would be bikeOther in the equals method, and string m, string c, int g, and int n in the constructor. Next are instance fields, which are automatically initialized. There is one copy of an instant field for every object of that class. So examples include the strings model and color, as well as the integer gear. Lastly, class fields are like instance fields, but there is only one copy of the variable for all objects in the class. And an example would be the num of wheels. So a common error that students make when trying to create a new object is that they'll type in bike B1 and they'll think that they've created a new object. But what they've actually done is they've only created a reference variable to an object that hasn't been created yet. So as you can see, when I type bike B1 and then I try to display B1, it returns null, meaning that the reference B1 points to nothing, or there's no object in the memory for that location. To actually create the object, you would have to input bike B1 equals new bike and the appropriate parameters. For example, RC, blue, 5, and 2. Another common error that students make is that if they were to create their own constructor, Java's default constructor will not work, and they're unaware of this. So when they create a new object in our class using the word bike b1 equals new bike with no parameters, they'll get a static error. This shows that there's no constructor that matches that invocation, since the only constructor that exists is one we've created, which takes in the 4 parameters for model, color, gear, and number of wheels. So to create an object in our class, you'd actually have to include the 4 parameters. And here's an example. Note that you can create your own constructor, and doing so does not always require parameters. You should also remember that changing a private variable for one object will change it for all other objects. For example, if I were to change B1's number of wheels to 3, this would also change B2's number of wheels to 3. Sometimes you don't want this to happen, so you should avoid using a class field for that value. Another easy mistake to make in Java is to try to compare objects using the equals operand, double equals sign, such as b1 equals b2. Students expect this statement to return true when the objects are of the same value. However, this is not true because when comparing objects, the value is not compared, but instead the references to the objects are compared. So, if I were to write b1 equals b2, it would return false, even though b1 and b2 have the same values for their instance fields. To compare objects, you would need to create an equals method, which compares each object's instance field separately. As you can see, we've created our own equals method in our program. It compares each object's model, their colors, and their gears. And if all those values are equal, then you can say both objects are equal. So if I were to input b1 dot equals b2, it would return true now. Lastly, when creating your constructor, an example of an error you can make is instead of typing this.model equals m, you might write string model equals m, since you know that the model is actually a string variable. But instead of changing your object's instance field to the value you want, this will instead create a local variable called model and give it the value that you inputted instead of changing your implicit object's model. So here you can see an example of that. So when I try to display B1 now, it'll give me the value null for the model, even though I wanted it to have the value RC. So to fix that, I would have to get rid of the string, and I would have to put this.model instead. So those are just a few of the common avoidable errors you can find when writing and debugging a Java program which uses objects.